Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Let me just turn on my preview screen to see if I'm... Hi Lalit, it was scheduled for 29th of December at 3 p.m. by mistake. Okay, it would be live now. Okay. So can I have a quick +1? Okay, fair enough. Seems like I am fairly audible as well as visible. Let me lower down the quality, but still, can I have a quick +1 so that I know that I am visible or audible or not? Okay, so let's start. Today we would be discussing interview series which was scheduled on January 2, 2022. It is the first interview series contest of this year and it was scheduled on 7 p.m. IST and this was of Juspay. Okay, the first question was maximum weight node and the second question was largest sum cycle. Okay, the first question was of 40 marks and the second question was of 60 marks. Now let us move to the first problem statement. Okay. Okay. I'm able to send messages. Okay, I just thought that no one is able to send messages. So we are given a maze with n cells. Okay, n cells. Each cell may have multiple entry points but not more than one exit point. So suppose this is a cell. Okay, and there can be multiple entry points. Okay, like this, but there can be only one exit point. Okay, you are given an array edge of n integers where edge I is what contains the cell index that can be reached from the cell I in one step. Okay, from cell I, so from I to edge I. This is absolutely very important. Fair enough. Then edge I is -1 if the cell doesn't have an exit. If it is -1, then it does not have an exit. Okay, this means that it is like this. Like this. Okay, the task is to find the cell with the maximum weight. Okay, we need to find the cell with the maximum weight. Now what do we mean by maximum weight? Okay, is the cell in sum of all the cell indices of all cell pointing to that cell. Okay, it means that suppose there is a node like this, and if there is one cell, this is 3 and this is 1, this is again 3, so the weight of this is 7. Okay, fair enough. So may I just see quickly why people are not responding? Okay. Okay, is there something wrong in the chat or people are not responding? Can someone just send me a dot at least so that I know, because I think something is wrong. Okay, still let's continue. If there are multiple cells with the maximum weight, return that with the highest index. Suppose 2 is having a weight 100, 3 is having a weight 100 and 4 is also having a weight 100. Then we need to return the highest index, that is this one. Okay, thanks a lot. I thought people are not responding. Thanks a lot. Okay, that's absolutely fine. Okay, the cell are indexed with an integer value from 0 to n-1, and if there is no cell pointing to the ith cell, then the weight of the cell is 0. Okay, now let me demonstrate you this also. Okay, suppose this has no incoming. If it has no incoming edge, then the value is 0. Okay, value is 0. Now let us solve the given test cases. So this is 0, this is 1, this is 2, this is 3. Okay, so what we have written, from index I to edge I. This is what is written from cell I in one step. Okay, from I. Okay, so from I to AI. Okay, so from 0 to 2 we have one edge. From 0 to 2 we have one edge. Okay, from 1 to 0 we have one edge. Okay, suppose this is 1 and this is 1 to 0, we have one more edge. Okay, fair enough. From 2 to minus 1, this means that there is no edge. From 3 to 2, 3 to 2, we have also one edge. Okay, fair enough. Now, what are the different weights of each? So, one has no incoming edge. So, one has a weight 0. 2 has one incoming edge, that is 1. So, 0 has a weight of 0. Okay, sorry, 0 has a weight of 1 because it has this one. Now 2 has an incoming edge of 0 as well as 3. Okay, so 2 has a weight of 3. Now 3 has also no incoming edge, so we can say that yes, 3 has also 0. Now, which index was having the maximum? This one is having the maximum. That is why the answer is 2 itself. Fair enough. So let me just block this person. Okay, you're not explaining the whole question properly. Okay, fair enough. Okay, by the way, just a request, Ayush, if you don't think my explanation is not up to the mark you expect, then you can just keep quiet and not disturb this. Okay, fair enough. Now suppose this question, as we have drawn, we can just write this only. Okay, number of incoming edge to a particular index. So what we can do is, let us take again this example only. Okay, now suppose we have this. Okay, so can't we do this thing like what we did? We, for 0, for 1, we kept everything and then we calculated. This same thing can be done in the terms of programming too. Like we would first take out the indexes 0, 1, 2 and 3. Now let's make an array. Okay, let's make an array like this. Okay, fair enough. And 0, 1, 2 and 3. Okay, so this is 0, this is 1, this is 2 and 3. Fair. Now let's start filling this. First we would start fill everything with 0. Initially the value is 0 for everyone. Now from 0 to 2. Okay, from 0 to 2. This means that 2 has a weight 0. Let us see. 2 has a weight of 0. So we would just add 0 to the index 2. Okay, so we have added 0. Now from 1 to 0. If we have from 1 to 0, then we would go at this index, add 1 to it. Okay, then there is no edge here because it is minus 1, so we would ignore that. Then we again have a edge from 3 to 2. So that means that 2 has an incoming edge of 3. So we would just add 0 plus 3. So 0 plus 3 is equals to 3. Now this 0 would be updated with 3 itself and everyone else is 0. Now we would start from the back. Why we would start from the back? I would tell you that. Suppose we have everything 0. Then we would consider only the highest index. That is why to consider the highest index first, we are moving from the back. And you can do that with using an explicitly if statement, but you can do it. So moving forward, suppose this is 0. So for now, we have the index 3 with the weight as 0. Then we encounter 2, which has more weight. So we would update this to 2 and with the weight as 3. Okay. Then everyone else is less. So we would say that this is our answer. Fair enough. Now let us move to the next problem. Okay, now let us move to the implementation. The implementation is quite easy. We would first initialize a vector of integer, everything 0 at first. Now, if it is not equal to -1, that means that if an edge exists, then we can say that add that to the answer, and then we would first say that yes, n-1 is the answer with the 0, because n-1 0 is the answer initially. Okay, then we would start moving from n-1 to 0. If the current weight is greater than the weight that we have, we would update it and update the answer also. Whatever is the answer, at the end we would return it. Now what we would do is, I would still wait for 1.5 minutes and you can ask me anything. Okay, now let's wait for 1.5 minutes. Okay, let me just check the comment quickly. So you should keep quiet. Why I'm not, you are not explaining why I am okay. Hi Sid, how is it going? For me it was not so good. I could only solve first problem. Yeah, for me I was the video editorialist, so I have the access. So I am not allowed to give the contest. But still the questions were very nice. The second question was, to be honest, very much nice. Okay, very much standard. So quickly tell me if this is clear or not. If you have anything to ask, you can ask me again. I would be more than happy to explain you. Okay, just tell me the line number or whatever. Suppose let us go to the previous and you can tell me the line number now, and I would be telling you where what is done what. Let me remove the annotations too if you want. I would quickly remove the annotations. Now you can ask me whatever you need help with. Okay. Okay. Yes, DFS is the right approach, but there is one property which we would study. And can you do the dry run? Yeah, why not? Let's do the dry run too. Okay, so let's take the test cases and start doing the dry run too. So initially we have the vector of size n with everything as 0. So initially we have 0, 1, 2 and 3, and initially everything is 0 itself. Now if ai is not equal to -1, then only we would proceed. So first we have a0. So 0 is not equal to -1. So we would add this to 0. Okay. So let's go to 0. So 0 to 2. Okay. So we would update the 2 as 0. Okay. Then we would come here. From this is what? 1 to 0. So 0 has an incoming edge of 1. So we would update. Okay. We would update 0 with 1. Then we would proceed. This is equal to -1. That means that an edge does not exist. So we would ignore that and we would move forward. This is from where? 3 to 2. So 2 has an incoming edge of 3. So 0 plus 3, that is 3 itself. So now the array elements are 1, 0, 3, 0. Now we would start iterating from the back. So till now we have encountered 0. So 3 index and 0 is the weight. Next we have 3 as the weight. So this is the maximum weight till now. So we would update this to this and this would be updated to this. Now we would come here. Now this is 0. This is less than what we have encountered. So we won't update it. Next we are encountering 1. This is less than what we have. So we won't do anything, rather move forward. And this iteration is finished. At the end we would just return this answer. Okay. Now Nikita, is this clear or not? Can you please code it in Python? Okay, I am not that much well accustomed with Python. So what you can do is after the stream, you can just look at the solution in Python and you would get it. Okay. So Nikita, is this clear for you? As soon as you reply, I would be moving forward so that I have a upper band for your this waiting. I would have a waiting of 1 minute. So quickly tell me if this is clear or not, or do you want more explanation over something, and then we would proceed. Okay. Okay. Most okay. Thanks a lot, Nikita. Okay. So fair enough. Okay. Okay, fair enough. So we have a maze with n cells. Okay, each cell may have multiple entry points, but not more than one exit. By the way, I respect everyone's opinion, but he was kind of spamming the whole message section. Okay, and it was kind of very distracting. He has been doing this for the last 3-4 classes, and it's very depressing thing. Okay, so it's very hard to move on without seeing this. Okay, that's why I kind of provide this. Okay, can you please tell me what is the best way to revise the essay? Yeah, I would tell you that, but after this. Okay, after I have completed this explanation. Okay, so you are given the same question with the same maze with the entry point and exit point and the same level of edges, but here you need to find a different thing. What you need to find? The task is to find the largest sum of cycle in a maze. Okay, largest sum of cycle. So suppose we have a cycle like this, we have a cycle like this, we have a cycle like this. Then suppose the sum of this cycle is 1, this cycle is 2, and this cycle is 5. Then we need to report this one, that yes, 5 is our answer. Okay, this is how it is made. So we need to first find the loops, and we need to find the maximum sum of all the loops, and we need to return it. This is what we need to do. I hope this is clear. So now first we would talk about loop in directed graph, because this is a directed graph. Loop in directed graph. Okay, fair enough. For the people who don't know about this loop in a directed graph thing, you should consider learning about what is back edge in a graph. Okay, back edge in a graph. Okay, and there is a thing that if a back edge is present, okay, if a back edge is present, then a loop exists in the graph. Okay, if present, it means a loop. Okay, this is what is there. Fair enough. So now for the people who don't know what is back edge, consider reading about it, because if I just explain you, that won't be enough. You need to just see which is a back edge, because its definition is kind of very confusing. So just do one thing, just draw the whole DFS of a particular graph, then learn about what is back edge. Okay, now let's move forward and see how can we do that. To do that, let us understand about a simple property. Okay, a edge can be included, okay, at max once in a loop. So according to this property, a edge can be included at max once in a loop. it can't be included twice. Okay, so what we can do is we can consider all the loops that is there in the graph, and then we can find the maximum of it. Okay, now we would see the implementation, then we would continue the explanation. So what we are doing is, it's absolutely very simple. We would first find all the cycles in the graph, and the maximum of it will be our answer. Okay, okay, so what we can do is, first there would be a DFS function. In that DFS function, whatever are we visiting, we told that every edge would be included only once. That is why we would first mark this as edge. Okay, mark this edge, and then we would make the parent of this edge. So initially the parent would be -1. After that, suppose this is 0 and this is 2. So 2's parent would be 0, and 0's parent would be what? 0's parent would be -1. Okay, let's move forward. Now what we can do is, suppose let us see a particular graph. Okay, suppose I have 0, then I have 1, and then I have 2. Fair enough. So suppose I visit this 0 with the parent, and this is also cycle. Suppose this 0 has a parent of what? -1. Then I entered that thing to the temp. Now what is this temp? I would tell you that. So I enter this 0 to the temp. Then we move forward, okay, and mark this as visited. I would just write 1. This is not visited. Okay, so we would start doing DFS from this point. Okay, now from this point we would first go to this side. This is also not visited, so we would start the DFS from this point. Okay, and we would keep inserting all this. Okay, after this, 1 would be inserted and this would be made as visited. Now this would be visited and this would be made inside this thing. Now what to do after this? Now suppose I reach the point where this is already visited. Okay, if this is already visited, what we would do is, if the node is not equal to I, we would first include that. So we say that yes, let's include 2 to our answer. Now answer is equals to 2. Now what is the parent of 2? Parent of 2 is 1, so we would include 1 to our answer also. This is what is there, sum plus node. Okay, now again we have 0, so we would again include 0 to our answer also. Now 0 has a parent of -1, so we can say that we would return from this point and then we would just enter. Now the temp has a 0, 1, 2, and the answer is what? The answer is 3, which is the sum of this loop. Okay, now what we would do is, we would come back directly here. We would take out, if it is not visited, we would do a DFS from that point. And whatever we have visited, as I told that every edge would be included in the loop only once. So whatever edges are included in that loop, we would make them as 2. Okay, this means that this has been included before only. So we would just write 2 here itself, and we would clear this vector and again use it. Okay, now what is all this? All this is nothing but making the vector. So we are saving the vector in vector of int, that is visited array, and this is vector of vector int of making this whole vector graph, and this is vector of int which would indicate the parent. And why this parent thing is needed? Suppose we have 0, then we have 1, then we have 2, then we have 3. So 3's parent would be 2, 2's parent would be 1, and 1's parent would be 0. So this kind of helps us to move to the path at the start of the loop. So from the end of the loop, we can go to the start of the loop. Like if we are said that we want to retrieve the path of loop in a graph, we can retrieve them by going to the parent, then his parent, then his parent, then his parent. Okay, like we do in disjoint union. Okay, disjoint set union, like we go to the parent, then parent, then parent, we go till it is a parent of itself, we go till that. The same thing would be applied to here. If you know disjoint union, then it would be a more easy, because the same kind of concept is used here, akin to that, but not the same thing. Okay. So quickly tell me if this is clear or not. Okay. Now, is this thing clear or not? May I have a quick yes or no? If you are not getting the reply, let me remove all the annotation, and tell me if you want an explanation of any line. If you want an explanation, just mention the line number and I would do it. Okay. Okay. Could you go over the solution once again? Yeah, please. Why? Yeah, sure. Why not? Okay, sure. Let me go to the solution once again. Okay, so what we are doing here is that okay. So first we are making this thing visited. Suppose we have this 0, this is 1, this is 2, and this is a loop. So let's take the scenario of loop and you would understand. Suppose I say that yes, do a DFS from this point 0. 0 is initially not visited. Okay, then what I would do is, initially this is 0, this is 1, this is 2, and this is what? This is visited array, this is parent array. Okay, let's write this thing. Okay, fair enough. Let's move forward. Now we are first starting this thing from 0. So 0 is marked as 1. So this is visited. So this thing is visited. So we are just marking it visited. Then parent of this node is P. So initially its parent would be -1. Okay, fair enough. So now this is visited. So I would just mark this as visited. Then we are inserting that to the temp node. Okay, so now temp has a value 0 inside this thing. Okay, then let's move forward and find the neighbors of this 0. The neighbors of this 0 is 1. Okay, is this visited? No, this is not visited. So we would start a DFS from this point. So we would start a DFS from this point and the parent would be this node only. So if we start a DFS from this point, we would again come to this point. We would mark it visited. Then its parent would be marked as 0. Then we would push that to the temp. So we would push 1 to the temp and then we would move forward. If the neighbors of temp, if the neighbors of 1, that is 2, is not visited, we would start a DFS from that point. If we start a DFS, we would first come here, mark 2 as visited, and then the parent of 2 is 1. So we would mark this as visited. Then we would again come to this point, neighbors of 2. So neighbors of 2 is already visited. So if this is already visited, this if statement would not work. This would work. Now what is this if statement? So we would first go to sum of I. Sum is equals to I. So first sum is equals to 2 and here it would be added 2 also. Sum is equals to 2 because 2 is now. Then we would go to, if node is not equal to I, node is not equal to I, so we would go from 2's parent is what? 2's parent is 1. So we would go to 1 and add that. Okay, add parent of this node. So we would add this 1. Then 1's parent is what? 0. So we would go to 0 and add that also. So 2, 1 and 0. Then it is equal to -1 and 0's parent is also -1. So we can say that yes, both is equal. So we would break out from this point and we would return the sum itself. So we can say that the answer to this is 3. So now first tell me if this DFS thing is clear or not. What will happen if there is a loop? I have shown you the visited array, the parent array, what is stored in the temp, and how the sum would come. Tell me if this thing is clear or not. May I have a quick yes? Then I would move to next thing, again explanation. No problem. Okay. We can solve this by using DSU. Yes, you can solve this using DSU. Can I solve this after learning disjoint set? No, disjoint set learning is not important. Learning is not required. You just need to have a good hold over graphs and DFS. That is enough. Okay, just learn about what is this parent and node, how to find loop in a linked list. Okay, sorry, loop in a graph. Okay, so first tell me if this thing is clear or not. Please do tell me. Then I would move forward. Okay. Okay, many people are having a problem, so quickly tell me. I would still wait for 1 minute. Quickly tell me and say this thing if this is clear or not. I have no problem in explaining again. That's absolutely fine. Quickly tell me if this is clear or not. Only one people replied. What about Parashmani Thakur? And what about Anon? And what about Maneshwaran and Anna Tiwari? Okay. Can we use unordered map to solve this? Yes, but kind of avoid using unordered map because unordered map has an average time complexity of big O of 1, but worst time complexity is big O of n square. So if the test cases are very random, then you might encounter a big O of n square, and even if you have the correct approach, your solution would fail. That is why. So please kind of consider removing that. What if there is a -1 in an index? If the index is -1, we won't include that to our answer. We would see to it. Okay, we would see to it. That's absolutely not a problem. Okay, fair enough. Thanks a lot. So let's see. Okay, so first we have told that this thing is a vector of integer. This is the visited array that we have made. This is the V. This is the graph vector of integers, and this is the parent one. This is just like this, visited, parent, and this is the graph itself. Okay. Now, if the edge is not equal to -1, then only we would include that. Okay. This is very important. If the include is not equal to -1, then what we would do is, suppose there is an edge from 0 to 2. So we would just say from 1, then push back. Okay. So just we would write 1 dot push back 2. This means that we can move from 1 to 2. So from index I to AI. This is what is told. So we would first make this graph. Okay. So make graph. Okay. Then we would move forward. Okay. If we are moving forward, we would first check if this is getting visited or not. If this is not visited, then we would start a DFS. Okay. If we have started the DFS, what was the return? From here, the return sum was 3. So we would first write 3. And yes, till now the answer was 0. Now we have 3. So answer would be 3. Now, what there was in temp? Temp had 0, 1 and 2. So we would do what? We would mark 0, 1 and 2 as 0. So क्या कर रहे हैं ना, हम बस बता दे रहे हैं कि ये 0, 1 और 2 किसी और के लूप में यूज हो चुका है, ये आपके में नहीं है, और एक एज सिर्फ एक ही बार लूप में इंक्लूड हो सकता है. दैट्स वाई उसको काइंड ऑफ कुछ यूनिक वैल्यू दे दो, बिकॉज इन द डीएफएस फंक्शन वी आर मेकिंग द विजिटेड एज 1. ओके, इनिशियल इट इज 0, सो विजिट कर रहे हैं लूप के उस फंक्शन के अंदर तो 1 दे रहे हैं, तो एक्सप्लिसिटली और ऐसा क्या नया दे जो हो जाएगा. तो 0, 1 यूज कर चुके हैं तो 2 यूज कर ले रहे हैं सिंपली. Now, उसके बाद the thing that was there for 0, 1 and 2, now we are removing everything. The class is being empty for the next teacher to come. That is why we have cleared every vector, and then whatever is the maximum out of doing all this, we are returning this answer. So quickly tell me the line number which you are not able to understand. I would be more than happy. Then I would be okay. So clear, thank you. You are simply telling the approach but not explaining this. Not a good thing. So Aman Godia, I think that you are the same person again. Okay. So this is not simply getting an approach. This is the thing that finding a loop in a linked list which can be understood by backedge. So people who already know backedge and already know what is loop, and if they know that an edge can be included only once, okay, then there is no point in doing the explanation, exaggerating the same thing again and again. Okay. Okay. So quickly tell me if this is understood or not, or if you want any explanation regarding anything, let me know. I would do the noteful. Okay. Okay, by the way, a request to Ashish and his alternative account Aman Godia. That's a please a clear request that I'm not doing anything wrong. I'm just doing my job. I'm just a regular person who is trying to fit in his place. Okay, and I am trying my level best to ask everyone, to make everyone understand. Okay, and it takes a lot of effort. Okay, it takes a lot of effort. You need to be online in an OBS, you need to do all the setup and all this lighting, you need to prepare the questions, you need to prepare the slides, and you need to have a dual screen setup for this OBS thing. Next you are having a cell phone and this green screen setup and everything. Okay, this requires a lot of hard work, and out of all this you need to be very cautious that your notifications are not turned off. This is not turned on, this thing. Okay, because a single mistake and people would shower everything upon you. Okay, and it takes a lot of effort, trust me. I'm just a regular person working from home, and there are people, there are siblings of my house who make noises, and I need to persuade my mom to tell her that please don't make noises, I would be streaming, and I'm doing it online from a place like India. Okay, people are not shouting, I'm trying my level best, and the noise suppression thing, everything, my laptop is not that much top notch, everything. Okay, so please do understand the intensity and the amount of hard work I put in. Okay, just don't come and kick over my face and say that yes, you are not the one who can solve all our mistakes. Okay, yes, see, I'm full of mistakes, I know that. Okay, and I can't keep everyone happy, and that's fine too. But if you are having a problem, okay, let's sort that out in personal. Even if you don't want that, I'm very extremely sorry in whatever way I have hurt your feelings, but this seems that you have a personal problem with me. Please don't do that. Okay, I don't have any grudge upon you. Okay, just a regular person doing his job. And trust me, it's very frustrating. You have been doing this for 4 to 5 places. Just sit here at my place and you would know it requires a lot of effort. And you're just coming you without your profile picture, saying and going away. But it depresses your mind. You can't sleep properly because people out there are shouting on you. They're telling you that you're not enough. Okay, so everyone is doing their job and everyone is trying their best. Okay, directly don't kick someone on their face and say that yes, you are not the one. Okay, please do. Okay, okay, yeah, thanks a lot. Okay, still I would wait for the next 2 minutes. Okay, because this thing is clear or not, or just 1.5 minutes. Okay, for the people who just asked me, I would ask them again. Maneswari, Anand, and then Adventure, and then Parashmani Thakur. If this thing is clear or not, can I have a quick yes from you? You all. Okay, please do just tell me if this thing is clear or not. Okay, thanks a lot. Okay, so that's all for today. Okay, yes, it was using DSU but failed. Yeah, the DSU concept is being used, not the actual DSU. Like the binary search thing concept can be used, but not the actual binary search. Okay. Okay, so that's all for today. If you are seeing this after the live thing, so what you can do is you can ask me on LinkedIn your doubts and I would be explaining them. If a meeting is necessary, I would schedule a Google Meet meeting with you and I would do my level best. Okay, is there any other approach for this? Okay, I don't think there is any other approach, but even if it is there, this Hamilton cycle thing is the most simple. That's why I went forward with this. Okay. So good night, have a nice day, and all the best for your placements and for your next contest. Okay, and happy new year.